In our next session, Pioneering the Future of Chips Manufacturing, we delve into Intel Foundry's ambitious 10x Moonshot mission to fully transition into autonomous factories. Attila Lengyel, Senior Director for Market Intelligence and Strategy within the Manufacturing Automation team at Intel, will provide insights into how digital twins and the industrial metaverse are integral to this futuristic landscape. So Attila, Moonshot mission sounds quite intriguing. Please tell us more about that.
Nina, thank you very much for the opportunity that I can be here and talk about our 10x Moonshot. The title is very inspiring, so we will keep that inspiring tone throughout this presentation. And just talking about it, let's go to an inspiration that was there in 1961 when Kennedy said we need to put a man on the moon and bring back. And sure enough, within 9 years, it did happen. Now, it's really important for the semiconductor business this moment. It's actually created this current semiconductor business because when they really calculated what kind of compute power the Apollo mission would need, they realized that time, that current technology was not enough, and they really needed to research. That's really how our great founder, Robert Noyce, really secured many of the contracts for the Apollo mission and created a big, inspirational, amazing business we have. Now, what really happened here, I have a really good picture from Brian that we really need to focus when we think about inspiration. We need to focus on the future. We need to build the future. There is only one point in the future we want to get to. Problem solving is a little bit different. We try to solve current problems, but we learned from Gordon Moore, we have to focus on the dynamics of the industry, and we need to set where we want to go. So this is really where the moonshot starts. Okay, talking about the moonshot, it's easy to say, I want to be somewhere, right? So our mission with this project at Intel is focusing on the bigger picture on 2030, 2040. Yes, you establish a moonshot, you talk about it, and you really need to describe the futuristic moment that everybody can really understand, associate with, and relate to. That's, I think, the easy part. But we can say fully autonomous factory. But how do you really turn it back to now? And that's what we can learn from these great inspirational moonshots. Going to the next step, once you establish a moonshot, for example, when Kennedy said we have to get to the moon, of course, think about it. They didn't even have the rockets to get there. They didn't know how to land. So you start to think about possibilities. What are the theoretical capabilities that make the futuristic world possible? So if we talk about fully autonomous factories, now we need to really think about the possibility thinking, and we need to look at the gaps where we are. And the next phase is really critical, where you start to say, I need to hypothesis test, I need to learn. And throughout that learning, you're going to fail, and that's natural. We failed many times, we didn't get to the moon in one shot. We iterated through, we learned. And the most important in this learning, that failure gets into your learning because you know that path won't work. So you need to pivot. You need to do something differently. So instead of trying to think about this funnel as, trying many things and then the winner will lead. No, you have a vision. You try many things. You try to learn. And once you're ready, what becomes really that you get scalable new technologies like semiconductors. And you put that back to your execution and you run these new scalable technologies, you create your production solutions, and now you can 10x productivity, improvement through disruptive innovation. So the 10x is really coming here with the moonshot. Yes, but every step we take to the moonshot, we have to provide some kind of benefit. And what is less that we really shoot for, we're shooting not incremental innovation, but really shoot for disruptive innovation right away. So that's why it's hard to work with us, because we want to, what is disruptive, how to really go ahead. So this is really the thought process, how we went through. We have the vision, we listing those possibilities, those capabilities, we starting those hypothesis testing, and we're really looking for the disruptive technologies that we need. Now, let's just talk about what is semiconductor, because I think many of our audience might not really understand the massive scale and complexity what a semiconductor business really means. To build a semiconductor fab nowadays, it takes $20+ plus 20 billion plus. This is a very, very significant investment that we need. Those are some of the numbers that we have 1 million cubic meters of soil that we need to get out. We need to have 600,000 cubic meters of concrete that we need to pour. 7,000 people just building the factories. And we have a structural steel of 35,000, right? So these numbers are really significant and magnificent. Now, if you think about it, how it works, a semiconductor factory runs in 5 distinct levels. Many times when you look at our YouTube videos, you're going to really see a fully automated factory. So you could say, guys, you already have everything automated. What is this vision about? You need to see it holistically, as we heard throughout this holistic digital twin. Holistically look at it. We have the roof with a lot of different, equipment. Then below the roof, we have the air ducts that actually cleans the air. Then we have the clean room that everybody knows about, where the wafer is really going through process tools. We have 1,200 plus process tools with at least 2,000 autonomous AVG robots or AMHS robots that delivering the wafers. Now, on that level below, we have the sub-fab that has thousands of pumps, transformers, power cabinets that actually supplies back to the equipment. And below that one, we have the utilities. So think about the entire thing as a holistic. Any of those several tens of thousands of equipment go bad, go wrong, we have scrap, we have problems. So all those extremely complex systems together is what we're focusing on when we talk about fully autonomous fab. Now, we do know as we move forward, we are going to have to work with intelligent artifacts, right? So the idea is that, the Moonshot fully autonomous fab, we want to describe the environment it's going to happen in. And we know it's going to be digital. It has to be digital. So 2 key technologies that we're really looking for at this moment, we're looking for the digital twins, and we really want to deep dive into it, not incremental improvements, but what is the disruptive innovation in digital twins? So that's really the question that we're asking ourselves. And on the other side, the metaverse, where we will co-work together and create value together in the intelligent artifacts, is really, really critical for us. So between the two, we imagining there is a digital universe. And that is really, we use the digital universe as describing that complex systems and integration that you need to really make happen to enable these 2 technologies. And that the digital universe will seamlessly connect physical asset and intelligent artifacts and our employees and facilitate the free flow of digital data across unified platforms, accelerating co-creation. So the interesting thing is unified platforms. Now let's a little bit deep dive into digital universe. So what is our goal? Our goal is become the second largest foundry by 2030, most advanced, and as well the most sustainable. Now, if we look at technologies, what we do internally with our assets and that digital twin technology that we're looking at, we need to create exceptional value for our customers and stakeholders. So every step we will take together, it's a value add serving the customer. Now, those technology that we look for, digital modeling, we have to create the models, right? So you need to have that data models, you need to have the CAD models, you need to really have that data model. What is that assets really described in the digital world? Now you need the digital thread to load it with data. So now you have both the model and the thread. The next one is the big thing is simulations. We need to have that physics-based simulations what is our understanding how these digital assets should be working and what is the performance of it. Now once we have these 3 steps, then we can move forward and we can look at autonomous AI agents. We can use the simulation, we can use this to learn from it with some methods like deep reinforcement learning and any other learning that can help us to really assess what is the best decisions we need to make. And the last one, it has to go back to the physical world. So somebody or something needs to translate it back, and that's where we're looking at intelligent cyber-physical systems like cobots, humanoid robots, AMRs, those decisions that made in the digital world, now you need to bring it back to the cyber-physical systems. Now, that's really one side, how we operate. So we did believe that digital twinning and digital technologies will help us to really channel value toward our customers. However, as well, we need to have an exceptional Foundry customers and employee experience, the human side. How do we really help co-create value? With the Interseal Metaverse, you have really good stations down there about how we can create immersive design and engineering. How we can, and the entire floor, not just here, the many other buildings, about virtual factory operations. We can establish that. We can have supply chain optimization throughout this digital world. We can have immersive employee training. We can have an employee to hop onto the metaverse and learn, how to operate the tool. And as well, which is really, really critical for us, education. As we're building more and more factories in the United States, we do need to have those tools available for the STEM education, the students, to be able to experience what semiconductor manufacturing is and see the beauty of this complexity and how engineering marvel it is. So we really would like to create metaverse for them to come in and work for us. Now, another very important aspect, these are exciting, great technologies. And, there is nothing that stops us to do all these. But we really need to think about positive sum automation. We want to create value together. And that value needs to be created throughout measuring the success, the team, the machines, the process, the systems. We really need to look at holistically. If we look at holistically from the digital twin perspective point of view, we need to look at it from the automation perspective point of view. So closing my presentation is about 10x Moonshot. We want to get to fully autonomous factories. That's really where we want to be. These are really the aspects where we want to get. And these are the technologies and sciences we need to get there. Thank you.
Thanks, Attila, for taking us on this impressive journey with you. A lot of technologies, a lot that's planned there. So I'm wondering, how are you collaborating with Siemens in realizing all of this?
Yes. I think, when Roland came out in his SES, in his presentation, and talked about building factories in the virtual world, I had a chance yesterday to talk to him about it, and it was really great and inspiring discussion that yes, you have to really organize and practice how great it is that you can have the virtual world where you can actually set up your operation, learn from the virtual, and once you get into physical, you already know what you want to do. So where we see a really great alliance with Siemens Visions and our vision here, and we actually signed an MOU. So we are mutually agreeing that we are going to work together in the next couple of years. As you can see, it's 2030, 2040. So we are going to work together on these, and that's where we see Siemens a very critical partner for us.
Cool. So you have to have the right partners. Nevertheless, it's a really ambitious plan. I already said that in the beginning. You also said it. So I'm wondering, what challenges do arise when the objective is to become the second largest foundry by 2030?
I think it's really two aspects. One is the technology. We are really working on the EUV technology to bring our 18A technology out and 5 nodes in 4 years. That's really a major challenge. We are moving and we are really advancing there. The second one is really how do we create exceptional value for our foundry customers? How we become serving them the best there can be.
It's always nice to give people a hands-on example. So yes. I'm wondering, can you give us a concrete example of how the industrial metaverse has been integrated into operations at Intel Foundry already?
The pandemic gave us a really good insight into we have to learn how to work digitally. And throughout the pandemic, we had a lot of program with the HoloLens and with other technologies. And right now, several of our factories, our technicians actually using remote operation and using this technology for operating some of the aspects of the factories.
Thank you, Attila, for demystifying what this Moonshot mission is all about. It was great to have you here on stage.
No, thank you very much for the invitation, and I hope I can update you next year how we are doing with this.
I hope so too. Thanks again, and goodbye.